Okay, before we start, can I please get a confirmation that you guys can hear me as well as see my screen? And YouTube as well, please confirm that you can hear me. Okay, so Assalamu alaikum and good morning, guys. Welcome back to grade 12 Maths by Inspired Teen. So in today's lesson, we are going to be continuing with functions, right? A really big topic, functions, where the last time we ended on discussing the different types of exponential graphs, which we'll revise now to begin with, and then we'll draw the graph and move on to slightly more complex things. Okay, and then hopefully next week we get to questions. We'll do some questions next week, and the following week we'll move on to three. Yeah, okay. So let's just revise what we have here. So we have the four different types of exponential functions. Okay. On the top, okay, the top two, we said that for both of them, okay, we can firstly see, okay, number one is these lines actually don't always represent the y and the x-axis. Okay, actually the vertical line always represents the y-axis, but this horizontal line is not always necessarily the x-axis, right? The horizontal asymptote, that's the main thing. It just so happens that in these examples, because there's no q, that this vertical line or the horizontal asymptote falls on the x-axis. Okay, but please note that the rules for where it's above or below, the rules for when it's above or below is when it's with respect to the horizontal asymptote. So when we talk about it needs to be above or below, we are talking about the horizontal asymptote. Please don't assume that it's just always above the x-axis or below the x-axis. Okay, again, we're working with the horizontal asymptote, right? So basically we have this general formula: y is equal to a times b to the power of x minus b plus q, where when a is greater than 0, that's when our graph is above the horizontal asymptote. So in these examples here, when we look at our examples for the actual functions, we see that we have 3 to the power of x and 1 over 3 to the power of x. Both have positive coefficients. So this is almost like positive 1. Okay, so this is almost like positive 1, right? And here we also have positive 1 in front. Okay, so both have a as positive, so we can see that they're drawn above the horizontal asymptote. Then it differs when we come to b. So when b is greater than 1, so as you can see here, b is 3, which is greater than 1. It's an increasing function, above and increasing. When b is between 0 and 1, okay, so when it's a fraction, it's above and decreasing. Okay, then we moved on to now when a is now less than 0, we go below the horizontal asymptote, and as we can see here, a is negative 1, a is negative 1 here. Okay, obviously we don't have to draw in that negative 1, but you do need to note that a in that case is negative 1, and b here is 3, and b here is 1 over 3. Okay, so in this case, when b is greater than 1, but it's a negative, okay, that means it's below and decreasing. Okay, remember we're just considering b. So when we consider b, it's just 3, not negative 3. So that's why we say it's greater than 1. Because you might be thinking like negative 3 is not greater than 1, but we're just working with 3. The negative 1 comes from a. Okay, so 3, when it's greater than 1, it's below and decreasing. When it's between 0 and 1, it's below and increasing. So the increasing, decreasing is opposite from top to bottom. Okay, then we can move on to drawing a graph. So they say, so in order to draw the graph of a exponential function, you need to draw the asymptote, not asymptotes, which is q. Okay, you need to draw the asymptote, right? Then you need to determine the shape, of course, right? Is it above? Is it below? Is it increasing? Is it decreasing? Okay, and then you need to determine the x and y intercepts. Okay, so let's do that. Draw the asymptote. So if we look at this example, f of x is equal to 2 to the power of x plus 1 minus 2, which is basically equal to a times b to the x minus b plus q. So can someone tell me, what is the, listen carefully, what is the equation of the horizontal asymptote? What is the equation of the horizontal asymptote? Okay, specifically, I'm asking for equation. Anyone? Okay, y is equal to -2. Okay, so y is equal to -2 is actually the correct answer. Okay, if we remember, q is our horizontal asymptote, which keeps the same sign that it has in the formula. Okay, so basically, whatever is added or subtracted to your exponential expression, or your exponential term, sorry, is going to be referred to as the horizontal asymptote. So in this case, our q is here. It's the term that's added to our exponential term, or in this case, subtracted. So that's our horizontal asymptote. It keeps the same sign. So somewhere along here, where x is -2, we have a horizontal asymptote. Remember, an asymptote line is that part of a function for which it's undefined. Okay, so the part of the function for which it doesn't touch. Okay, so now we need to determine number 2, which is the shape. Okay, so remember, when a is greater than 0, it's above the horizontal asymptote. When a is less than 0, it's below the horizontal asymptote. Right? When a is above, okay, and b is greater than 1, this is increasing. But when b is between 0 and 1, this is decreasing. Okay, that's for when it's above. Then when it comes to it being below, okay, of course, a has to be less than 0, so we have to have a -1 or negative coefficient in front of b. Okay, in this case, when b is greater than 1, it's actually a decreasing function. But when b is greater than 0, but less than 1, so between 0 and 1 essentially, it would be increasing, below but increasing. Okay, so that's how we determine the shape. When we talk about shape, determining the shape from a and b, that's how we determine it. So someone tell me, is this graph going to be above or below the horizontal asymptote? Is this graph going to be above or below the horizontal asymptote? Okay, why do we say below? Okay, two above. Okay, so it's not below because, okay, we have to look for the coefficient, right? We have to look for the coefficient of our exponential term. Is it negative or is it positive? Okay, so let me just give you some examples of some exponential graphs, like just equations. If I could have y is equal to -2 times 3 to the x minus 4 plus 5. Okay, I could have y is equal to 5 times 2 to the power of x minus 1. I could have y is equal to -3 to the power of x. Okay, let's work through each of them. Tell me for this one, is it above or below? Okay, I'm gonna leave this. I want you to always have this, right? So you can even memorize this and write it down in your exam. Like the first thing is you write that down in your exam and then you can always refer to it. right? So I'm going to leave this here, and I want to know our first function, increasing or decreasing? I mean, sorry, above or below? I can't tell which are old messages now, but I should be able to tell them. Above or below? Okay, what we can also do is we can write the general formula. Y is equal to A times B to the power of X minus B plus Q. So now we can see where A is, now we can see where B is. Correct, right? So this one is definitely below because A is negative. Okay, now tell me, is this increasing or decreasing? This function, is it increasing or is it decreasing? So you guys are correct with below. That's because A is negative, as you can see. So when A is negative, it's below. Right? Now, if we want to look at whether it's increasing or decreasing, we have to consider this guy, the base. Okay? While it's below, and B is definitely greater than 1 because it's 3, it's not a fraction. That's, according to this diagram, it says decreasing. So therefore, this one is decreasing. Okay, let's have a look at this example. Not increasing, guys. I hope you understand why it's decreasing. They swap. When it's above and B is greater than 1, it's increasing. But when it's below and B is greater than 1, that's when it's decreasing. Okay, please do note that and don't make that mistake. Okay, so let's look at the next one. Actually, let's change this to... Okay. Okay, so now y is equal to 5 times 12 to the power of x minus 1. Is this above or below the horizontal asymptote? Okay, please, horizontal asymptote, not x-axis. I have one above. Correct, this is indeed above, right? This is above the horizontal asymptote. Very good. Okay, so since it's above the horizontal asymptote, we can write it. Okay, what about increasing or decreasing? Is this an increasing function or is this a decreasing function? Remember to look at B and refer to our thing, diagram. No, thing. Okay, we have a few decreasings, a few increasings. Okay, this graph is actually decreasing, guys. Why? Because, okay, we can see that it's above. So as soon as it's above, we go here. Okay, so now that we're done working with A. Okay, because A is greater than 0. So we said it's above the horizontal asymptote. Okay, now why are we saying that it's decreasing? Okay, because when it's above and B is greater than 1, it would be increasing. But when it's above and it's between 0 and 1, it's decreasing. And we can see that B, which is a half, is actually between 0 and 1, and it is therefore decreasing. Let's color coordinate this. Okay, I hope that makes sense. B is less than 1 technically. That's correct. So just 1 second. Okay, cool. So hope that makes sense. Let's do the last one. Right? Tell me, this guy, is it above or below? Negative 3 to the power of x. Is this an exponential function that's above its horizontal asymptote or below its horizontal asymptote? Below, because its coefficient is negative 1, excellent, right? So this one is below the horizontal asymptote. Now tell me, is it increasing or is it decreasing? Is it an increasing function or is it a decreasing function? Okay, decreasing, excellent, because it's below and greater than 1. Okay. Cool, let's move on. Let's draw our graph. We said that we need to draw our vertical asymptote, which in this case is -2, which we've drawn. Now we need to determine our shape. Okay, so for our one, we said what? We said that it is, okay, let's go back to this one. B is not in that function. So you see, the thing is, right, B is in this function because when we have -3 to the power of x, it's like having -1 times 3 to the power of x. So A is -1, yeah. Sorry, A is -1 and B is 3. So how do we know that it's decreasing? Because A is -1, that tells us it is below the horizontal asymptote. So then we go to the next part of it. We have to look at these two. We have to look at A greater than 1, or is B, is B greater than 1, or is B between 0 and 1? If B is greater than 1, it will be decreasing, and ours is 3, so it's definitely decreasing. Okay, so let's move on here. If this thing can work with me, there we go. Okay, so for ours, tell me now. Let's work with this example. Is it above or is it below? 2 to the power of x plus 1 minus 2. It is definitely above because A is greater than 0. A is what? A in this case is positive 1. Okay, remember that always. Okay, so since it's above, now we can go to this next part. Is it increasing or is it decreasing? Is it increasing or is it decreasing? So essentially I'm asking, is B greater than 1 or is B between 0 and 1? So what is B? B is positive 2. That's A, that's B. Okay, hope that makes sense. Not decreasing, increasing. So in this case, because B is greater than 1, what is B? B is 2, which is definitely greater than 1. It's an increasing function. So now we know it's above and increasing. So I can draw a rough idea that it's going to look something like that. Okay, if you're struggling with the increasing thing, left to right, it's like a staircase, right? Remember we discussed this. Alternatively, you could memorize what the increasing and decreasing functions look like, right? You know, when you have it above, you have two options. It's either going to go away from the asymptote like that or towards the asymptote like that. Okay, the increasing one increases from left to right. So it's going to look again something like that. The reason we cannot draw it as yet is because we need to find the x and y intercepts, because this is going to touch the x and y axis. So the exact point at which the graph touches the x and y axis, we need to find. How do we do that? That's simple, that has never changed. How do you get the x intercept? By making y equal to 0. So y is equal to 2 to the power of x plus 1 minus 2. 0 is equal to 2 to the power of x plus 1 minus 2. Take 2 to the other side, it becomes addition. So 0 plus 2 is 2 is equal to 2 to the power of x plus 1. This is like 2 having 2 to the power of 1. My bases are the same, so they can cancel each other out. When they cancel each other out, I'm left with 1 is equal to x plus 1. I take 1 over to that side, it becomes 0. 1 minus 1 is 0, so therefore x is equal to 0. So where does it cut the x-axis? At 0. Since it cuts the x-axis at 0, we should expect it to cut the y-axis at 0, and the y-intercept should be 0 as well. Okay, how do you get the y-intercept? By making x equal to 0. And again, we are expecting an answer of 0 because it's the x and y intercept, right? Y is equal to 2 to the power of x plus 1 minus 2. Y is equal to 2 to the power of 0 plus 1 minus 2, which is basically 2 to the power of 1, which is 2 minus 2. Y is equal to 0. So that's just confirmed that the x and the y-intercept are at 0. So now we can draw a graph. It's going to be increasing and above. So it doesn't have to look perfect, it just has to look somewhat right. The shape has to be right. What about the vertical asymptote? In an exponential graph, we don't have a vertical asymptote, only a horizontal. In a hyperbola graph, is that when we have a vertical asymptote, the one we did last week. So, yes, that's how it looks, right? It's past the origin again. Sorry, it's not like 100% past the origin. Maybe let's redraw that. But something like that, right? And then you show with both arrows, you show on the side it's approaching -2 forever and ever and ever. It will never touch -2, okay? Because remember, -2 is an asymptote. Okay. So yes, that's it. Done. Drawn. Okay. So I hope that makes sense. Drawing a graph of exponential. Okay. So here what I have is just basically just a quick summary of the equations that we did and more or less the shapes of each graph. We have a linear function, or which is known as a straight line graph, or straight line function. It has the equation y is equal to mx plus c, which is what we use. Don't really use that. And this is the shape. Okay, it's basically a straight line. We have quadratic functions. Okay, so now you might be wondering, why are there more than these three? Because these are the main three that we learned, right? We learned that this is standard. We learned that this is TP, and we learned that this is x-intercept form or root form. Okay, so these are just basically, like, for example, if you consider this guy, f of x is equal to ax squared. As long as it's a square, we know it's a parabola. This graph basically looks like this. It has its turning point at origin, and it does that. That's what y is equal to ax squared looks like. So if we have y is equal to ax squared plus q, if we have y is equal to ax squared plus q, where q is just added to the y value. Okay, so q is basically a vertical shift, shifting up or down. And yeah, it would just be shifting up or down, where if it's ax squared, it just starts at origin. Then it's our normal standard TP x-intercept. Hyperbola, excuse me, hyperbola or hyperbolic function. Y is equal to a over x plus p plus q. So they have the first one, in case the question doesn't have a p. It not having p basically means what? It basically means if there's no p in the hyperbolic function, it basically means that there's no vertical asymptote, just a horizontal asymptote. Oh, sorry, I take that back. Not that there's no vertical asymptote, but the vertical asymptote is 0. X is equal to 0. So it's on the y-axis. Okay, so that's why it's like plus 0. So it's no, you don't have to write p. Okay, but yes, nevertheless, here is the equation. Sorry, here's an example of what the function looks like. Please do remember and go through the videos again if you need to, the axes of symmetry and how to draw them, right? Those are important. Then we have the exponential function, y is equal to a times b to the power of x plus q, or a times b, times b to the power of x plus p plus q. Okay, remember we said that this is horizontal shifting. Okay, shifting left and right. The negative p. There's no exponent. There's no vertical asymptote. Okay, so don't assume that that's a vertical asymptote. Okay. Okay, sorry, quickly, just before we continue, I'd just like to take like a 2-minute break. I just need to go to the bathroom quickly and you guys can freshen up. I'll be back shortly in like 2 minutes. Okay, cool. Let us continue, please. Please, the Q&A. Okay, cool. Let's continue. So let's talk about distance in functions. Okay, so we have steps for determining distance. We have vertical distance. Okay, and we also have horizontal distance. Let me get my notes. Okay, so we have vertical distance and we have horizontal distance. In functions, when we talk about vertical distance, okay, we talk about the top y value. So we say y top minus the bottom y value, we say y bottom. Okay, so remember vertical is a vertical line, so it's a straight line. So essentially we are saying A minus B, right? The y value of A, minus the y value of B. If we want the distance between A and B, provided that A and B, okay, the vertical distance, the vertical line between A and B is vertical, right? It's not skew. It's not a diagonal line. It's a vertical line. Okay, so we say y top minus y bottom. Then vertical distance could also be, so remember, okay, so we said y top minus y bottom. So top graph minus bottom graph, which is basically y, because remember you have y is equal to ax squared plus bx plus c. So y does represent the graph as it is. Okay, y does represent the graph. So then substitute the given x value to derive your answer. Okay, cool. steps for determining horizontal distance. Okay, so we can also get horizontal distance provided that 2 points are there's a horizontal straight line between them. This is x right minus x left. That's the formula that we follow. And find the applicable x values, and you say that AB is equal to XB minus XA, or largest minus smallest. Obviously, remember taking a negative into consideration. Obviously, positives are bigger than negatives. Then we talk about this, which is important. Steps for determining maximum or minimum distance. Maximum, so you'll see depending on the question that you get, you'll be determining the maximum distance or the minimum distance. Both follow the same method, okay? So that's fine. Now, determine the vertical distance equation, okay? So if it's a maximum distance, which it generally is, between a maximum distance of a vertical line. So if we look at this example again, we have AB. They want the maximum distance between these two graphs. Essentially, that's what they want. They want the maximum distance between the straight line and the parabola. Okay, so between A and B. So what you do is you determine the vertical distance equation. So you'll say vertical distance is equal to top graph minus bottom graph. Now, the reason I said equation is because actually we are going to use the equations. You'll see when we do an example, we are going to use the equations, okay? And we're going to subtract the actual equations because we want maximum distance, okay? And then we find the x turning point. Now, why do we find x turning point? So you'll see again, it will make more sense when you do the example. When you subtract the two graphs, you formulate a new equation. Okay, so that you basically have a new parabola equation, and then you get xTP and you get yTP. So why are you finding the turning point? Because remember when we discussed turning point, we said turning points are maximum and minimums, right? So that's exactly why we are doing it, because they wanted maximum distance or minimum distance. We found the expression for that equation, and then we found its maximum or its minimum value. So its maximum or its minimum value is its turning point, number one. And yeah, number two, when we get the yTP, that will tell us. So it's specifically the y turning point that is the maximum, okay? Maximum or minimum length. So you have to find the y turning point. Okay, cool. So let's do an example, right? So we're not going to do all of this, right? We're not going to do this whole question. We will eventually, but for now, we're just going to do the last question. So let's fill in some of these blanks that we need. So this equation that you have to solve for, g of x, it is equal to 2x minus 6, and f of x is equal to x squared minus 2x minus 3, x squared minus 2x minus 3, okay? Let us copy that. Okay, so we have the two equations of the graph, and that's all we essentially need. Right, it says T is a point, okay, on the x-axis, and M is a point on F, such that TM is perpendicular to the x-axis. TM intersects G at P. Calculate the maximum length of PM. Okay, let's go see what in the world they are talking about. So they say T is a point on the x-axis such that M is a point on F such that TM is perpendicular to the x-axis. So that's some way to start. So it's given in the diagram as well that TM is perpendicular to the x-axis. So now, if it's perpendicular to the x-axis, you need to understand that it's a vertical line, okay? Because remember, what else is perpendicular to the x-axis? It's the y-axis, right? Okay, the y-axis is perpendicular to the x-axis. Okay, and the y-axis is vertical. Since they're both perpendicular, they're both parallel to one another. But the main point is that they are both vertical lines. Okay, especially this line that we are currently working with. Okay, it's a vertical line. So, okay, that's established. Then they say TM intersects G at P. TM intersects G at P. Okay, there we go. It intersects the straight line at P. Perfect. And then obviously the parabola at M as well, right? Then they say calculate the maximum length of PM. So this is basically maximum length between two graphs. Now someone tell me, so for PM, this I'm calculating this maximum length. So why do they say the maximum length? Because remember, PM, a distance, is basically a distance between the two graphs. I could have this distance between the graph, I could have that, I could have that, I could have that. But they're asking where's the maximum point, and this is how we do it. So first tell me, okay, g of x is my straight line, f of x is my parabola. At P and M, like at that x coordinate, which one is above? Is g of x above or is f of x above? Is g of x above or is f of x above? Okay, excellent, right? We can see that g of x, our straight line function, is above the parabola function, and that can be substantiated by the fact that p is above m. Okay, p is on g of x and m is on f of x. So p is above m. So whenever we're calculating, remember, we've established why it's vertical distance, because that line is perpendicular to the x-axis. This is vertical distance. Then we upon furthermore reading, we understood that, what did we understand? That they actually want the maximum vertical length. So when they ask you to calculate the maximum vertical length, you are first going to do vertical distance. So y top minus y bottom, right? Meaning the equation of the top minus the equation of the bottom. Okay, that's going to give us a new equation. Now, I need to add something that I forgot. Okay, so y top minus y bottom, that's why we had to establish which one is on top. P is on top and M is below. Oh, yeah, so I was going to say, we don't have, okay, we don't have these x coordinates. It's x and y. So we can't just say y, the y value on top minus the y value at the bottom. That's not going to work. And besides, they want the maximum, okay, not at a specific point. So what we're going to do is we're going to calculate vertical distance between PM. That's going to give us an equation that represents the vertical distance between these two graphs for when g of x is above f of x. So it's going to give us the equation to calculate any of these lines between the two graphs where g of x is above. Okay, so essentially what we are going to say is, because it's y top minus y bottom, the y, or the graph that's on top, is g of x. The graph that's at the bottom is f of x. I'm going to say g of x minus f of x. And this is going to be equal to the subtraction of their functions, right, of their actual equations. So we said g of x is 2x minus 6. Okay, then I'm subtracting and using brackets because there's multiple terms for what I'm substituting. It's x squared minus 2x minus 3. So I'm taking the equation of g of x. Okay, again, in this question we had to work it out, but because we're skipping to the last question, I just wrote it down for you. Okay, because g of x is above, that's why I'm saying g of x minus f of x. So 2x minus 6 minus x squared minus 2x minus 3. Okay. Okay, cool. So now we're going to do subtraction. Okay, so I'm going to say 2x minus 6, and I'm going to distribute the negative inside to all three terms. So negative x squared, positive 2x, because a negative and a negative, and again positive 3x. Sorry, just 3. Positive 3. Right? So when we simplify this like terms, okay, I have negative x squared plus 2x gives me plus 4x. Negative 6 plus 3 gives me negative 3 actually. So I have negative x squared plus 4x minus 3. So don't worry about the negative x squared. In this case, we're not factorizing, so we don't have to convert it all to positive, right? You wouldn't be able to in this case either way, because it's not an equation, it's just an expression. You could only take a negative bracket, okay, as a common factor. So now we basically have an equation that represents what? This equation okay, represents the vertical distance between the two graphs, between the two functions. Okay, however, only when g of x is above f of x. Okay, that's what it represents, and that's what it's going to give us, the vertical distance between the graph at any point, okay, as long as we substitute in a coordinate between the function when g of x is above f of x. So now, this is step number 1 done. Do vertical distance formula. Let's just revise. What is step number 2? Step number 2 said find the xdp, and then step number 3 says find the ytp, and the ytp is going to give us the maximum. So number 2, we're going to find the xdp. So xdp is equal to negative b over 2a. So negative 4 over 2 into negative 1. This is equal to negative 4 over negative 2, which is basically equal to 2, positive 2. So the x turning point is positive 2. Now, step number 3, find y turning point, and that's going to be our maximum. How do you find y turning point? By substituting it into any of the formulas, I believe. No, not any of the formulas, I lied. It has to be, of course, our new formula, right? Why is it our new formula? Because we are finding the maximum distance, and this is our distance formula. This equation represents the distance. The max distance, we're going to use, once you solve for xdp, you're going to solve for ytp by substituting your xdp into this equation, into our new equation. Okay, so this is equal to negative x squared plus 2 4x minus 3 2, okay, because that's the x turning point, negative 2 squared plus 4 open brackets 2 minus 3. So it's 2 squared, which is 4 negative, 4 plus 8 is positive. I think we're getting 5. No, we'll be getting. We're getting 1. Correct. Okay, we're getting 1. So basically, we are getting the value of the ytp is 1. Since the ytp is 1, you can also say, therefore, your answer, max length PM is 1. In this case, they don't give units, so it's just 1 unit. Okay, I hope that makes sense. So that's maximum distance. Minimum distance works exactly the same. Let's move on. Let's talk about the roots and parabolas. How does roots relate to parabolas? So roots, remember we said our x-intercepts. Okay, and then when we talk about our x-intercept, okay, we also talk about our something called the discriminant, which I believe we've discussed before. Now the discriminant is basically just that triangle, and it's equal to b squared minus 4ac. It's equal to b squared minus 4ac, right? Now for roots and parabola, so we deal with this discriminant, okay, and for each different case, we have a different case for our discriminant. So let's have a look at the first example, right? It says equal real roots, equal real roots. So I think, if I'm not mistaken, in the very first lesson, we discussed roots and what they mean, and we even discussed them in terms of parabola. So we're going to look at them once again, right? So equal real roots is basically real. The fact that the roots are real mean they exist, okay, meaning that the graph does have x-intercepts. Okay, when the root exists, okay, it means, sorry, when the root is real, it means that the root exists. What is a root? A root is an x-intercept. So it basically means that there is an x-intercept. Okay, but when the x-intercepts are equal, that means that the turning point is on the x-axis. Okay, Also to note, the equation would look something like this. Y is equal to A, let's say x minus 2, x minus 2. In this case, they'd have, so in this is x-intercept form, okay, they'd have two of the same factors. So it's basically like x minus 2 squared. That could also work, right? So they have two of the same factors. This is when they have equal real roots. And with regards to the discriminant, b squared minus 4ac, this b squared minus 4ac guy, this guy is equal to 0. And let's have a look at non-real or no real roots. So the word non-real means that the roots don't exist. Okay, since they don't exist, they doesn't touch, there's no x-intercept. So that's possible where it doesn't touch the x-intercept, and we can see these examples that will never touch the x-axis. Rather, they don't have x-intercepts, right? Then we look at the discriminant for this. The discriminant for no real roots states that b squared, when you do b squared minus 4ac, it has to be less than 0. Then if we look at real unequal roots, so real roots meaning they exist, they are x-intercepts, however, they are not equal to one another, they are different. And this is where you get b squared minus 4ac being greater than 0. Okay, so I hope that makes sense. And as can be seen in the diagram, we have two x-intercepts, and that's how it looks. Okay, so in this case, if it's drawn, actually the turning point is on the x-axis, then these would be the same point as one is negative, right? Same magnitude. Okay, I hope the roots and parabolas so far make a little bit of sense. Maybe we'll go to a question and talk about intersection of graph. So let's have a look at our roots question. Okay, so you get something like this. Okay, so again, right here, right now, it doesn't really matter what the function is or the question is, we can work with it just from this question alone. It says the value of k for which negative 2x squared minus x minus 8k minus 8x, sorry, plus k has two equal roots. So for now, this is fine, we're not about the function. Let's look at this, two equal roots, right? We always work with the discriminant. What does it mean for the discriminant? Let's go back. Two equal roots. Okay, here we go, equal roots. Okay, they actually are two equal roots. It means that b squared minus 4ac needs to be equal to 0. So I go back to that question and I say that b squared minus 4ac needs to be equal to 0. And I substitute in values. Here my a is negative 2, b is negative 8, and c is just k, right? Remember, the variable k represents, it's a variable, so it just represents any number. So we'll be able to sub it in accordingly. So b squared minus 4ac needs to be equal to 0. I need to solve for k. Again, why do I need to equate it to 0? Because it needs to have two equal roots. So b is negative 8, so I'm going to say negative 8 squared minus 4 into negative 2. C is k is equal to 0. Okay, this is 16. No, I lied. This is 64 plus 8k is equal to 0. 8k is equal to negative 64, and k is equal to negative 8. If all the corrections are correct, then it should be correct. Or if all the calculations are corrections. Okay, so the value of k for which negative 2x squared minus 8x plus k has two equal roots, for which values of k, okay, or the value of k, in this case, one single value. Why did I say b squared minus 4ac is equal to 0? Again, that's simply due to the fact that it has two equal roots. That's why we equated it to 0. Okay, and then yeah, you get negative 8. Okay, before we leave, let us just start off to discuss intersectional graphs. Okay, then we can continue next time. So steps for determining points of interception, okay, or intersection, doesn't really matter. you have to equate the two functions, okay? Because at that point, the two functions are equal to one another. So you equate them, right? They have the same x value, they have the same y value. So essentially here you're just saying y is equal to y. It's like the same thing, right? Then you solve for x. Okay, look for the applicable x value a or b. Substitute the applicable x value into any of the equations to find y. Okay, so next time we will continue where we left off, which is here. We will do increasing, decreasing, and then interval notations. Okay. Cool, perfect. Thank you guys so much for joining. Okay, so early in the morning. I wish you guys all the best. Have a good week of school. I know maybe some of you are on holiday or done or whatever, but yeah, all the best. And I will see you guys next week, okay? Thank you guys. Jazakallah khair. Assalamu alaikum.